Hello, I'm Matthew Davis with Kingsman Homes. We're out here in beautiful Texas on this foundation that's about to be poured. I'm here with Jeremy with Builders Post Tension. We're going to be talking about this foundation and foundations in general. Jeremy, if you'd like to talk a little bit about Builders Post Tension and what you do and the company does.
Yeah, thanks Matthew. So my name is Jeremy Linzer. I'm with Builders Post Tension. We're a post tension supplier out of Houston, Texas. We service Greater Houston, DFW, Bryan College Station, and all the in-between markets. So we are a PTI certified plant, and what we do is we provide post tension and concrete reinforcement materials for home builders and concrete contractors in and around the Greater Houston
Jeremy,
market.
if you wouldn't mind just kind of giving us an overall background of where post tension came from, where it originated, and how we got to where we are today.
Sure. So post tension has been around for a long time. It's been around since the 50s in large infrastructure projects such as bridges or any long span infrastructure, elevated structures.
Yeah, on the civil side of things.
Correct. So it's been engineered. The science has been around for a while. It wasn't applied so much on the residential slab on grade side until about the 1970s, 1960s, and it started here in Texas because of our wonderful soils.
Yeah, highly expansive soils, especially in the Houston area. Out here we have a ton of sand. We have those really expansive soils, clay and whatnot.
So people realized, hey, there's got to be something better than just throwing 6 pieces of number 5 in a beam, and we're spending all this time on makeup and material and additional concrete. So they decided, hey, let's apply this technology to the residential slab on grade side. So what we're basically looking at is it's still a concrete foundation, but it's going to be reinforced by high strength steel cables as opposed to pieces of rebar.
Yeah.
And once you place your concrete, the concrete's going to cure, and after that, that's when we will come back and we put those cables under stress, and we compress each cable, and it puts the whole slab under compression, and that's what gives the structure its reinforcement.
So essentially, like, the main difference between a traditional rebar slab or conventional slab and a post tension slab is that a post tension slab, after the cables have been stressed, it's under active tension.
Exactly.
So it's actively being reinforced.
Yes.
Through several thousand psi of the cables being tensioned.
Yep, that's exactly right. So we come and we pull each cable to 33 kips, which is 33,000 pounds per square inch. And then it eventually settles down to about 27 to 28 per engineer specs on each cable. So that's a ton of force on your foundation, which is good because that's compressing and that's what's holding your whole house up.
Yeah.
So it's really a great piece of technology, and we're happy to provide it for y'all.
Yeah, so what I typically see, like in a remodel setting on these older homes, they're either rebar or even a mesh support system for the foundation. You'll see that your concrete does great when it's under like a compression, but its tensile strength is very weak. So whenever concrete gets in a little bit of a bind, like a hump or something like that, a corner falls off, that's where you get that cracking, that's where you get that upheaval. So like with the post-tension slab, what you have going on is that active tension. So it's actively keeping tension to keep the whole entire foundation floating as one cohesive unit on top of the ground.
Exactly. And if I can add just one thing to that, the floating slab's a great way to think of it. And with us being in Texas and extreme weather, whether it be heat or wet or rain, whatever the case may be, you need to have a durable slab that can weather those storms.
Exactly.
Right? So whenever you're floating, if say one side of your house is dry, it's going to allow your slab to move as one structure and go with the earth underneath it.
Rather than having like a corner fall off or something along those lines.
All right, so what we have here is what we call a live end. So this is a 1 to 2 foot tail that's going to stick out the side of your slab, and once the concrete is cured, it's been placed and cured, and the forms have been removed, our crews will come out and we'll take a hydraulic ram. There's going to be a small void around the cable. We're able to put that ram on the cable. It bites into the cable, and that's when we apply the stress. It actually pulls the cable. This is a plastic sheathing, and this is the steel cable that's greased within it. So there's a steel anchorage on both sides, and the steel anchorages are going to compress right here. So as we're pulling this, the anchorage right here, and the anchorage on the dead end, which is nailed into the form board, is going to compress the concrete. And we just do that one by one until all the cables have been stressed properly.
So Yeah, so all these cables are running the entirety of the slab, front to back, left to right. So they go end to end. They don't stop in the middle anywhere. So they're compressing it from the outside in. And one thing I want to point out further, and kind of one of the misconceptions of post-tension is its repairability. So from the remodel standpoint, one of the downsides of post-tension is moving plumbing when you're doing a remodel. However, if you do end up accidentally busting one of those cables, it can be rethreaded because, just like you mentioned, it's a cable ran within a plastic sleeve that goes across the entirety. So they can actually rethread that cable and redo the tension on it if needed, if it busts.
And we do repairs as well. And if you have a remodel, you can come and detension a cable. If you know where you need to cut in relation to where in the house you need to access, we can come and detension those cables.
Yeah. So that's kind of one of the, like when you're talking about pros and cons of which type of slab, traditional slab on grade, that you're weighing back and forth. A lot of people talk about the reason to do cables or to do rebar instead of cables is for the remodelability of it down the line. But you can do remodels and move plumbing fixtures, rethread, detension, and retension these cables as needed. If you've ever seen one bust, it is quite a violent thing because they are under, like we said, several thousand pounds of pressure. So it'll like more or less explode out both ends. But it can be repaired and rethreaded.
Correct. And with proper installation and a good builder like yourself, those things are going to be minimal.
Yes.
But even when it does happen, you're right. It's very repairable.
Yeah.
It's not a problem whatsoever.
Yeah, and that's kind of one of the misconceptions of a cable slab. One of the benefits of it is ease of install. My makeup crew was able to do this in like 4 or 5 hours. This is over 3,000 square foot of foundation. So they had a crew of 5 or 6 guys out here and they were able to do the entire foundation. The cost, obviously you're using less materials in terms of metal. Rebar is really expensive right now, so we're using significantly less rebar. There still is rebar reinforcement elements to this, but the cost of material and labor is significantly less, and that's one of the bigger draws as to why you see cables being used. But what I like about it is the active tension element of it, keeping the slab all one monolithic pressure across end to end.
Okay. All right. So right here we have a live end anchorage. So this is feeding our beam going across the length of the slab. So these steel plates are what puts pressure onto the concrete whenever we come back and stress the concrete. So the concrete is going to be placed. It's going to settle all around the anchorage here. You're going to have even placement all around the anchorage. And now once that concrete is cured, what we come back, the live end is sticking out of the form board on the other side of this pocket former right here. And after the form boards are removed, we will remove this pocket former and it creates a void in the side of the slab. So that allows us to insert our hydraulic jack into that void right there, and we can grab the cable and stress it to the proper kips to give that foundation strength. And then after that, it's inspected, make sure the elongations are proper, done by the engineer of record. And once it's inspected and passed, we come back, we cut off the live end. So once we cut the cable, we'll come back and put a high strength grout in the pocket former in that void, and it seals off the end of that cable right there.
All right, Jeremy. So you got me convinced on a post-tension slab, but this is the country. This is Austin County. I want to do a concrete finish work, and I don't want to see those cracks.
Right. That's what we all want. That's what we all wish for, is a nice, beautiful finish. And what the post-tension slab can help is eliminate that cracking. It's not going to eliminate it entirely, right? Concrete is going to crack, unfortunately.
Yeah.
But with it being under compression, as we've discussed, it's any cracks that are shown. You might see it prior to the cables getting stressed, but as soon as it's put under compression, those little cracks are going to shrink right up. They're going to draw right up, just like that. So that is also going to help you get a nice, pretty finish on your slab.
So it doesn't make it a crack-free foundation.
Exactly.
Okay, because I've always heard there's 2 types of concrete. There's concrete that has cracks, and then there's concrete that's going to crack. So even with post-tension and the highest PSI of concrete, it would still crack. It just helps minimize those cracking by drawing them together because it's under active tension.
Exactly. It's where it's just aesthetic, and it's not going to affect the structure whatsoever, but it is still going to minimize the cracking compared to your conventional rebar.
Yeah, so the cracking will be less less obvious whenever you have that stained concrete
Yep.
polished floor.
Exactly.
Perfect. Well, all right, Jeremy, thank you for coming out today. Again, this is Jeremy and Builders Post Tension. Thank you. All right. Thank you to Jeremy and Builders Post Tension for coming out here and talking about this foundation. I just wanted to point out a few other key details and perhaps construction terms involved with a foundation, in this case, post tension foundation. So let's check them out. All right. Thank you very much to Jeremy with Builders Post Tension for coming out here, filming this video, using his expertise to tell us something about these cables that we're using on this foundation. But I just wanted to go into a little bit further detail about different parts and components of a foundation, since having a conversation earlier with my wife, trying to explain these things, I was like, I might as well include them in the video. So your foundation has a few components to it. The outside perimeter board is called the forms. This forms the outermost perimeter of the foundation. These channel looking things are what are called beams. And the engineer specs those to be at different depths and widths depending on your soils report, conditions, and what all is going on with the structure. These blue things here are obviously the cables, and then they're held up in suspension with chairs. One detail that you notice that we'll do is that we like to wire tie our chairs to our cables, because whenever you start pouring this foundation, it gets pretty chaotic and you have a lot of weight, moving part, people walking on it, and these chairs can get knocked off and stop serving their intended purpose. So wire tying to the cable helps them continue to keep those cables up off the pads. A pad, another point, is the part that's floated in between the foundation beams. For the most part, the depth of the concrete in the field, not in the beams, is give or take 4 inches for most typical residential slabs. So then after you do your forms, you dig the beams, you put the plastic on the top of the pads, you have what's called the makeup. Putting the plastic and running the cables and the rebar is what's part of the makeup process. So you'll see down here, we have some rebar per the engineer's specs along the bottom of it. So after the foundation is made up, is what it's called, we do what's called the float. And the float is what gives the foundation its shape. So that little step down in between your patio and your existing and the interior structure is separated during the pour from these float boards. So during the pour, whenever the foundation sets up, we start to pull these form boards off on the float and begin to finish them so they have a nice even finish. On this house we have a perimeter brick. Part of what you add during the float process is a brick ledge, 5.5 inches in this case. And then you'll see all these various random looking stakes with nails in them. So this is shot with a laser level by the finishing crew to make sure that we had it finishing at an even height across the foundation. So they'll remove these as they finish the foundation. You'll see these pipes here. These are called the plumbing grounds. They're basically all the sewer lines or water loops that are for the foundation that go into the slab, excuse me. What we like to do is we never like to run actual water lines in the foundation. So what you're looking at here is a loop for the island. So we have a hard pipe. In case anything ever happened to those water lines, we could then pull and run a new one. Same thing with the electrical. That blue Smurf tube is the conduit for it. One little detail too that we like to do is to bring the exterior water underground, because fortunately here in Texas we don't have a frost line, from outside to inside on an insulated wall, so that we don't have to worry about the main for our house freezing, or it has less of a chance. In that case, never say never. This area here is the garage. It'll be dropped slightly, so that's what you see going on here with this float. And over there we have the drop showers. We're going to be doing a flush transition shower, but to do that you have to pitch the interior of the shower to get slope to it. So whenever we pour the foundation, we drop that part of the foundation slightly, and you'll notice how the pad is dug out just the tiniest bit as well. We put these buckets around the pipes that need to be centered for drains, so we have a little bit of wiggle room if needed to put an offset drain, or to get the exact center of the shower, or in this case right here, the freestanding tub. One thing I always like to do is have my plumbers, regardless of location, city or not, in the city it's required to leave a tall stack filled with water in the event that any pipe gets busted during pour or prior to pour is more typically when it happens. We're still holding water, so we're good to go.